So in this section, we're going to do the limit as y goes to 0, 0 of 3xy divided by x squared plus y squared. When I plug in, always try to plug in first. I get 3 times 0 times 0 over 0 squared plus 0 squared, which gives me 0 over 0. This is indeterminate from Gal 1. Okay, means we can't determine it just by plugging in. We need to do further investigation. So here we don't know. The limit may exist, it may not exist. If the limit exists, then you must prove that the limit is the same regardless of the path that you take to get to that origin 0, 0. However you come in on that path, okay, it's got to be same thing. All right, so let's pick the path. Let's approach it zero, 0 along the path y equal to x. So let's come in along y equal x. So what does that become? This becomes a limit as x comma y, but y is equal to x, so this is x comma, replace the y with x to 0, 0. So everywhere you see a y, you put an x. So the y becomes x here. So this becomes the limit as x comma x goes to 0 comma 0 of 3x squared over, okay, x squared plus x squared is 2x squared. Okay, and what do we know about this? These two will cancel, and so you end up with 3 over 2. Okay, now for the limit to exist, it doesn't matter the path that you go to. It should always be 3 over 2 when we take that limit. But let's try another path. Let's approach 0, 0 along the path y equal x squared. So instead of coming in on 0, 0 in the y equal x, let's come in along the y equal x squared path, okay, into 0, 0 here. All right, that's my x naught, y naught point on my open disk. Okay, so if I do that, everywhere I see a y, I'm going to replace that with x squared. So this becomes 3x times x squared over x squared plus x squared squared gets me the limit. X comma x squared goes to 0, 0 of 3x cubed over x squared plus x to the 4th. Now, if I simplify here, they all have an x squared term in there, so this can simplify to the limit as x squared goes to 0, 0 of 3x over 1 plus x squared. Okay. And so what's going to happen now is whenever I plug in a 0 for my x and a 0 for the x squared, I get 0 over 1, which is 0. Now, what do you notice about this path? Takes you to 3/2, while this path takes you to 0. Okay? Since these two things right here are not equal to each other, that tells us that the limit does not exist. Therefore, the limit does not exist since we didn't converge to L for all paths to the point 0, 0. Okay? All right. So just to recap, if it's indeterminate, so you get 0 over 0, the limit may or it might not exist. It could exist, okay? But if the limit exists, that means that you must prove that the limit is the same regardless of the path that you take to get into that origin or whatever the point is that you're taking the limit towards, okay? So if you can find two paths, if you think a limit doesn't exist, the way to show that it does not exist, okay, is to pick a path and pick another path and then see if these two paths lead you to different limit values. And if they do, then that tells you that the limit does not exist. Okay? All right. So in Cal 1, we only consider the limit from the right hand and the left hand side of a function. But in Cal 3, we must consider infinitely many paths through the disk to the point x0, y0. The limit from every direction has to be the same for that limit to exist. Okay? So let's talk about definition here. Definition 12.2.3, continuous. Okay? Continuous. So let a function f of xy be defined on a set S containing the point x0, y0. Okay, if limit as x comma y goes to x0, y0, f of xy is equal to f of x0, comma y0. Then f is continuous at x0, comma y0. Okay, that is, f is defined. All right, remember we need three things for continuity. You need it to be defined. Okay, so f is defined clearly here. It equals something that's defined. Okay, the limit exists. When I take this limit, I get some output, and then both of those things are equal. Okay, so those are the three things implicitly found in there to prove that the function, the multivariable function, is continuous at a point xy. Okay, so everything works in R3 the same way. And here, like it's in an open disk with your point x0, y0, and that's in R2. Yeah. In R3, what do we have? We don't have an open disk. We have an open ball. Okay, so imagine a sphere. Okay, do my best to draw this thing. And then in the middle here, you've got a x0, y0, comma z0 point. And then it's this open ball going around. Okay, so instead of a disk, it's a ball. All right, So that's going to conclude this video.